Today, everyone has access to a ton of information. But you know what's still missing? Trust. Where did this information come from? Did I hallucinate it? Can I actually rely on it? Tools like GPT and Perplexity are already giving citations, but does your app do the same? Let's fix that. Let me show you something magical. Yeah, this weird looking string, right? That's how Google highlights a specific text on a web page. So let's say you want to highlight a particular line on a website. All you need to do is copy the line, add the magical string to the end, and paste the text. Let's test it out in a new tab. See, automatically scrolled and highlighted. Pretty slick, right? But there's a small catch. If you paste the text row, sometimes it won't work. That's because browser actually expects it the URL encoded version of the text. In our case, the text is pretty clean, just some normal words and spaces. But if it had something fancy like commas, slashes, hyphens, etc., yep, it will fail. But don't worry, I will tell you the solution for this at the end of this video. Now that you know how Google highlights the exact text, let's build a full citation engine that automates this. There are just 6 simple steps for that. Let's try to understand them with the help of the flowchart. At first, user enter the query and we will use any search API, either EXA or SERP, to search for that query and get the list of URLs. We'll then scrape these URLs and pass their HTML to the LLM code, and we ask it to get the key points and the exact paragraph from where each key point came, and we will repeat the whole procedure for the whole list of URLs. At the end of this LLM call, we will have this type of object in which we have an array of key points and their exact paragraphs. We then use the exact paragraphs and the URLs to generate the cited URLs. We will then add the cited URLs and IDs to the previous object. Now, many of you might be thinking why we add the ID. It is just to reduce the token count for the next LLM call. If we don't add IDs, we need to send this whole object to the LLM call, but now we will only send the key point and the ID. The job of this LLM is to give the quality output by deduplicating the previous list of key points. The response structure of this LLM will be an array of key bullet points along with the IDs of previous key points. One key bullet point can be made up of multiple previous key points. Now at the end, we'll just replace these IDs with their respected cited URLs. And yeah, we are good. I have attached the link of a presentation explaining this whole process in detail in the description box, in case you might want to check out. Now let's see how the whole flow looks like in the actual code base. So I have built this engine as a small service which you can integrate with the agentic architecture very easily. This is a simple post request with get info as the endpoint, and it will accept the product name in the body, and then it will call the get info service. In the get info service, we will be using exa for searching content and firecrawl for scraping the content. We will search the name received in the body with the exa, and then we will scrape the URLs returned by it using the scrape URL function of the firecrawl. Then this is the prompt for our first LLM call. It will return us the output in this JSON format. After then, we will use this text fragment and the URL to generate citation URLs. I will show you the citation URL function after this flow. Then we will append the IDs. IDs are basically just simple sequences on the first come first basis. After then, uh, this is the prompt for the second LLM call, and it will return us the list for the bullet points. At last, we will add the citation URL as the hyperlinks in these IDs. So now let me show you the generate citation URL function. In generate citation URL function, as I told you in the beginning, browser expects URL encoded version of the text. So we are supposed to encode the text. This is the encode function that I have written. Before encoding, it is suggested to normalize the text, to remove extra spaces, trim the first and last spaces, and so say some fancy keyword doesn't get encoded properly. So I have shown the example of how you can encode it manually. So I have encoded for hyphen. Its encoded version is %2d. Similarly, you can encode it for any fancy keyword that you might face. That's it. After this, we simply add the string and the encoded version of that text and return the frag URLs mean the citation URL. Let's just test it out. The application is running. We just hit the post. This is the post request with get info endpoint, and the product name is set as Apple Vision Pro. Test it. We receive the search query as Apple Vision Pro. These are the search results from Exa, and we are scraping the URLs. This is the result from the first LLM poll after we added the citation URL and the ID. As you can see, the IDs are sequential form. We also received the result of our second LLM call, which is in bullet points. So this is our final response where we have added the citation URLs for the respective IDs as hyperlinks. Just copy and test it out. Okay, so let's see where this text comes from. Okay, highlighted. Check the next one. Yeah, this is working great. These are some extra pointers to make the engine more efficient. So that's all, guys. Let me know if you have some doubts in the comment section, and thanks for watching.